Good morning. So yesterday we were trying to decide if the gravitational force was different as the object moved up than as it was moving down.
Tanda kesang anju khari chirlana tagchedi polo de ya yu wa da ma sagra digapsu ya droe kapsu da ma yu e kapsu thinshu jora se khule thinshu di minda yor res landi le res.
So some people say it is the same, some people say it is different.
Khashi gi chikpare leidu khashi logar kheba yor laidus.
And we asked you to do an experiment comparing the time that it takes something to go up to the time that it takes for it to fall.
Tanda tagchi ji chires tagchi dil khari chirlana polo de ya yu ni kangla do map sagra di ya do du gola thoje thoshe dil lagba ni lu ni jini ya thoshe bodule gi thuze jora di da gang ni ma sa ya thuze jora di ni dure res.
So what did you decide?
Ingran so tagchi khari chins chikpares. So the time taken by the ball by going up and when it falls down, it's the same.
So the time seems to be the same. The time for it to go up seems to be the same as the time to go down.
The ya dwe da ma saya tu ju jura chikpare kenzo chikpare us thong soas chikpare le ros.
How does the speed with which it leaves my hand compare to the speed with which it hits my hand?
The lapal lu ne chinia dini ya dura dini ma li ra lu du da ma lapal tabe jura dini para gi jokse di khandes dos lu du da saudu. Okay, it hits your hand faster. And some of them are saying it's the same.
So let's think about the speed that it has when it passes this point on the way up and on the way down.
The dini ta indasa polo di ya do da ma sagju jura di jokse di taroshis lagba dinin sejan.
Is it moving faster when it goes up? Is it moving faster when it passes this point as it goes up than as it moves when it goes down?
Dini shtun so dini ni ya do polo di thengchi ya do ri chik ma sagu ra dini gi thuzu le kheba do da jokse le kheba thong du es thanda ta je nang so athara kheba du mindus. Okay, few of them are saying there's a difference, but most of them are saying there's no difference.
It seems that there is not a big difference.
Dusta do kheba chimbu thong mundo asti.
It seems that there is not a big difference. So what did we decide? We decided that the time it takes for it to go from here to here is the same as the time that it takes for it to go from there to there.
The kheba shira thong mundu lara diladu gola di woni ya dwe dida kani wole jura dini thuju chikbo do thong yu ras mangyung kore jura chikbo gurgu ras.
And the speed on the speedometer here on the way up is the same as the speed on the speedometer here as it's coming down.
Ya dudu da ma sa du yura kisi thanda jose jelse jua di yo aina chikba tungu ras.
So we have to decide what that means for the acceleration on the way up to the acceleration on the way down.
Tanzu di go su gugu yures di thanda ya dudu nyurnen da ma sa du nyurnen jura di go su gugu yures.
So imagine the ball's speedometer. Let's say that it is moving at 20 meters per second when it goes up.
The polo di jose ta oina jose jilche dil koi jose khazu tungor la oina 20 meter per second karcha chigla and meter nishu to rest jose de.
And it is moving 20 meters per second on the way down when it passes this point.
The gangnia ma dura dinne di tundu dinne ni ma do gola yan jose ta oina ma do gola tharanja karcha chigla and meter nishu to rest.
And let's say it takes 2 seconds to go from here to the highest point.
Ta lagwa dini ne chine ta ne thoshu jura ya those thoshu de polo do se di bodu ta oina ani karchani gurgu res.
So it moves up with 20 meters per second here, and it slows down, and it takes 2 seconds for it to reach the highest point.
Dilodu dini ya do teru du res ra. Ani ya thosho jura di le bodu ani karchani gurgu res. 2 seconds you said, right?
And then it takes 2 seconds for it from the highest point to pass this point where it moves with 20 meters per second moving down.
Adi ya ma do du gala ani karchachik la meter ni shu do du gala thanda thosho jura dini ni ma le du gala karchani gurgu res.
So the speedometer on the way up does this from 20 to 0.
Thanda jose jelche jua di ta waina nishu yora nishu ne ni ma sagyo res.
And on the way down it does this from 0 to 20.
Hine ma sagdu khande jugor lana lego yora ni la lego deni ni nishu lu dugu res.
In the same amount of time.
An tuju manglo khaju gorgor lana chiko chikyam gorgu res.
So the acceleration is the same
Dila du nyurnen di chikpa chade res.
because it changes its speed by 10 meters per second for every second that it moves.
Dila du jose jure jora di karcha chik chilo yogu cheo kapso yuwa di khaju dugor lana ani karcha chik la mirror chu dugu res.
So it moves 20 meters per second. 1 second later, it moves with 10 meters per second. 1 second later, it moves with 0 meters per second.
Karcha chik la du gala ani thanda karcha chik doe kapsu karcha chik gurgura di parala ani mirror chu dugu res. Dije le niwo del le du gala ya nishu gurgu res.
1 second later, it is falling and is moving with 10 meters per second. 1 second later, it's moving with 20 meters per second.
And thana shi ma sadu gala ya karcha chik gordu gala mirror chu di doe res. Thana shi engyo karcha chik dodu gala ni mirror nishu chagyo res.
So if the acceleration is the same on the way up as it is on the way down, what does that tell us about the net force on the way up compared to the way down?
Ta thanda ngazu nyurnen di ya dodu imba nere ma le du inere chikpa re la roa di la du gala ani di lo kho khari ligyo res. Ngazu thanda changshu juya di khande juya res dila.
Why don't you discuss this with the other monks in your group?
Ta nyurnen chikpa re la roa an changshu khande juya res ngobu dil roa an di kheran zuru khan nanglo pensu chodur nangro ches.
We have established that the ball on the way up has the same acceleration as it has on the way down.
Ta thanda nyurnen di ta oina polo di ya yu roa ya yu du nyurnen di da ma sagdu nyurnen di chikpa chikyang res.
What does that mean about the net force that it is experiencing on the way up to the net force that it is experiencing on the way down?
Ta polo di ya rodu da ma le du yora ya rodu gala khoran la changshu khande ji de gya shay res thana shi ma sadu gala changshu di ta oina khande ji res polo di la.
So you were asking about the meaning of the word net force.
Kyan so tiwa chik dos tiwa dikhar lana changshu lana khari res lani.
So on an object, Bryce, there are several forces that are exerted on him.
Ta thanda ngobo cha shawana Bryce chagyo res. Ani kurang ngobo digala ani shuk mang phasu gya shagyo res mangbuch.
There is the gravitational force
Shuk chi khari cha dior lana tenshuk di res.
on Bryce by Earth.
Shuk di gyasa Bryce la gyap che gya hindi se khola res.
There is the force on Bryce by the floor.
Ni shuk chi khari gya dior lana thanda Bryce kala thanda shala di gya dior res.
There is a force that I'm exerting on Bryce.
Na shukji khari lana stematis ki Bryce la gyadi res.
There is a force that karma is exerting on Bryce.
Shukji ngi Bryce la gyadi res.
There is a new force that I'm exerting on Bryce.
Ta shuk saj le res di stematis ki gyadi res ya.
No single force is more important than the others.
Ta shuk di khechere di chiklaya jora durni di khechere lan dine yo mares.
If Bryce will accelerate, will be determined by the sum of all the forces.
Ta Bryce ki nyurnu jura di khari ithak jo chigir la oina shuk khajo gya yo changme kyondom shuk jura dombe shuk digi ithak jo chigir res.
If the sum of all the forces is 0, then Bryce will not accelerate.
Ta di shuk changma domni thama di drumde lego jira go yo oina Bryce yogu chig mares.
If Bryce,
We should say that the force of gravity pulling me down compared to the force of the floor pushing me up, the sum of that is 0.
Ta dende shi oina sa se khole ithen shuk ma thingi yora thana shi shale shuk digi ya bigu yora dini da ta oina kyondom lego chagi yo oina ani Bryce yogu chig mares.
So the net force in the vertical up and down direction for me at this moment is 0.
Ta thanda khajo ta oina shung la ra ya da wo gang da wo la ora di dombe ani shuk di lego rimba ina yogu chig mares Bryce.
but the net force on the horizontal direction is not 0.
Hinaya thanda shuk di thanda tadu gala thela ta oi baina ani shuk di net force kyondom shuk chang shuk di jo du res chezam Bryce yogu chig res.
The net force is the sum of all the forces,
Ta thanda chang shuk lana khandi ji lagor lana shuk chazan dombe kyondom shuk jura dinde jil lagu res.
so I was pulling on Bryce this way,
Stematis ki Bryce la phajo thingi res.
karma was pulling on Bryce that way,
Ani nge Bryce la chujo thingi res.
If you're not convinced of that, look at my fingers.
Yichi mene kyan de chi si da sange zugula.
and after Bryce started to move, there was also friction between his shoes and the floor.
And Bryce yogo chidugala an kiran su thanda darshu di thanda Bryce ki hango di da shala baral darshu di yo res.
So Newton's second law connects the change in motion of Bryce, the acceleration of Bryce, to the net force on Bryce.
Ta thanda dendim niwa jora digi khari khari do tingor la oina Bryce ki thanda nyurne la jo do jora di da ani changshu jora di para do tingu res.
So let's do, no, that's okay. So is this an answer to your question about the net force?
Ta thanda changshu la do di thuwa di ani len di thepsu esa thanda ma dishish kyensa len thepse seu chase. Yes.
So we established that the acceleration of the ball was the same on the way up as it was on the way down.
Onzu thanda ngel takche na thonga na shi thanda nyurnu jora polo di ya tudu da ma saudu nyurnu jora di chikpa res.
Why is the ball accelerating?
Polo di nyurnu khachi ni nyurnu di choro lagora da res chungu res.
The Newton's second law tells us that the ball is accelerating because the sum of all the forces exerted on it is not 0.
Ta nyurnu di khachi ni ligir lo aina polo di la khais na kyondom shuk jora changme di ta aina legor yo mares cheza polo di nyurnu di tingu res.
So if the acceleration is the same on the way up as on the way down, what does Newton's second law tell us about the sum of all the forces on the way up compared to the sum of all the forces on the way down?
Ta thanda polo di ya yutu da ma saudu nyurnu chigre la ra dende indu gala Newton ki tentim niba di khari lagyo res. ya rodu gala kyondom shuk ta tanda changshu di khande jure thana shi ma saudu gala kyondom shuk changshu di khande jure slan Newton tentim niwa gi shi sung shwa na khande yores lekor chikpare ya rodu nyurnen chikpa ya rodu nyurnen jura polo dila ma yondu nyurnen jura dini chikpar res la ra takchilina di yindu gala Newton tentim niba jura di shi sung shwa na ta dila tanda changshu jura ya rodu changshu da ma rodu changshu khande jures la thiwa chikpa res okay the net force is same in both cases
The net forces will be the same.
changshu di chikpa ruas
But we said there are not many forces exerted on this ball on the way up or on the way down. There is only one force.
tanga ju she tu ruas der tanda polo di ya tang du da ma sa du ra ya ju du da ma sa du di gap su tanda shuk shira gya yo mare shuk chikran ju res dila
So the sum of all the forces exerted on it on the way up or on the way down is equal to that one force.
dila du gala ta shuk chikran ju res ra tanda del shuk mangbu gya yo mare polo dil an di tanda kyondom shuk chang shuk ju ra polo di ya ju du imbainare ma sa du imbainare kyondom shuk di ya ju du da ma ju du ni ga ga ji chikpa cha de res ya ju du kyondom shuk ju ra di da ma sa du kyondom shuk ni ga chikpa res
정말 슈바들이 다들 좋아하지 셴바체 내가스케 말이 이네 다들 가르서 맞고 동슈들 정슈들 다도 왔어 다들 동슈세는 고대도 정슈들에 정슈세는 로고야 다 지센터 줘라 미드 다도야 디 가르치는 자충 간데지 지금 다요레스
예서라 디 가정이 기들을 피가 너무 네트워크 동
kyondom shuk ter
네 저기다게 kendoshi 된또 노데레스 kendo시를 시 용도야 당바를 좀 보느라 이 말에서 정시생 아니 저기를 가서 장하 수수 뒤지더라 얘는 되게는 맞아 정시지대 이제 정시지대 가서 장하 수지대 장하 수지기 가르라고 그러나 슈몬보지야 당그라 뒤로 시카시 세리제는 매바 찬로라 세리제는 매바 찬 디 장마 장주 소세 슈고를 한조 줘라서 하마 정시생기 어딜라 그래서 슈 단다 야자도 마자 레거런드라 파자도 수제도 레거전 드니칠 하용그라 하마시 어딜 장하 슈생기 네트워크 생기 딜 주여레사 정시 생기더라 야세도 마세도 센단테라 다 한조 줘라 어딜 레사 이게 장마제라 한조 슈더라 선선 장하 슈더 선선 장슈가 전부 정슈지
So the net force is the sum of all the forces.
ta thanda changshu lai di khari lawor lana dombe ni shuk sangma dombe di chagi res
In the same way that if I owned 100 rupees, but I owed karma 80 rupees, the net wealth would be 20 rupees.
ta ngala nge lakpa la khari lana gumu gya res ani stomatis khoran gumu gya res ani ngala gumu kejute gu res dila du gala ta stomatis langu khaju yor lawaina gumu nishu yor lagruas
So is that okay?
this is cha suesadi
Good. All right. So, since the acceleration was the same on the way up as on the way down, the net force must be the same on the way up as on the way down.
ta nyurne jora polo di ya rodu da ma sa du chikpa res an che zan tanda sangshu die ya rodu da ma rodu ni ga chikpa res
And since there is only one force that is exerted on the object, either on the way up or on the way down,
ta thanda ngobu jura ya yuktu da ma sa du ya rodu inare ma sa du inare dile shu gya ge chikran chig yoras
that is the net force.
shuk chikran jura di shu di khar chagor lana changshu di cha de res
And so then, what does that tell us about the gravitational force on the ball by earth on the way up as on the way down.
Ta di la du gola thanda ngobo jura di ya do du da ma sa du sai tenshu jura di khande jures. It should be the same.
It should be the same.
Call chung do re. Ya do du. Further it goes away from the surface of the earth, the gravitational force reduces.
If it goes far away from the surface. So the idea that was mentioned here is that the gravitational force, when you move far enough away from the earth, it is going to decrease.
The kyanzu is samsu kharishir law sai ngwe jura dine ni khagas ki tha ring wa draw na ngobudi ani tenshu di mama cha du years lan she sons.
But for distances that are small compared to the size of the earth, we can treat the gravitational force as not changing.
Dila du galata to ni she oina se khule cheju jura di da ngobudi ta oina kheba shu do sara dila du gala ani tenshu dila kheba shira ching mares na di.
If I go and I measure the gravitational force on these skates,
Ta thanda di kholosh do dila ta tenshu ta wainas
here and on the second floor,
dela chikta ra tenshu di thana shi toze niwa gal zani chikta wainas.
will I measure the same thing or will it be different?
An che ge du gal chikpa thungure na kheba du res. It would be the same.
I need to go very, very far away to see a difference.
Dila du kheba thungu na tharungu shu dogo ki roas.
So then the gravitational force, we can treat the gravitational force as the same here, 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 here.
Chesang ta thanda kyangda shtuen so dindel ta du gala tenshu chikpa chi res. Polodi.
Okay?
Seo cha sesani.
All right. Now we would like you to do something in your group.
Ta thanda khari chugla na khiran zuruba na la che res ta.
Okay? Bryce, catch. We would like you to draw a force diagram in your group for an instant when the ball is between my hands and Bryce's hands.
Ta thanda shu gi remote yo chego shi sa gela khorani digi ani remote di khari ga thugurla na ngobo di thanda stomatus ta Bryce ki pharla yo ekapso suje labo ma cha la ora digi ne dan di samlo nishani ani shu gi remote di thuro chis. Kela di samba na inji mi ji sharo chia sa samlo na khorani ga thanda stomatus ta Bryce nikal polo labo cha yo mares labo ma cha yo kap gi ne dan jura di samlo nishani ani shu gi remote di thuro chis.
We want you to pick a point which is an arbitrary point, not a special point, not the point, for instance, that is halfway between me and Bryce, but any point.
Tas anda stomatus the Bryce ki khorani gi pharla yor lara bol polo di inchi mi ji ki takta le du ne dang jura tirang thigu yo mares Bryce ki dam tina re ta khot tina digures ne khari juna digures inji mi ji ki takta de gu yo mares.
What do these have?
Di da den zo khari chungyo yo resa.
Da politin position whereas ya use so whereas ye di laban dogora di do di di politin di tongo jogri do dusra
Yoksera. So it represents the speed of the ball.
ini on the chori do.
So here's a drawing from one of the groups.
The rugachi gi remote chi res di.
I'm not sure which one is me and which one is Stomatus.
Ta dina ha hum dulas. Bryce khandi res Stamatis khandi hong dulas.
But we don't care about which one is Bryce and which one is Stamatis.
The handsome one is Stamatis.
Kemal Bryce we Stamatis khandi hong dulas ra. Stamatis korang ziga de Stamatis res adini nang.
We only care about the ball.
Tangazo kharil thina chigorlana polo dil tagi res.
And this group has only one force acting on the ball.
Tadi ruka digi shuk chik ranji tishas dina ra. Chik randus.
This is the force of gravity on the ball by planet Earth.
Andi shuk di kharil shalana se khule ithin shuk di polo lagya jo dit shas.
Okay, that's this group over here is drawing.
Tadi ruka chigirela du ruka di remud res.
This group
Ani ruka shimba digis.
had several more forces acting on the ball.
Tadi ruka di khartun shalana polo digala shuk mangbush kya digyo thanda thewa mangbush kya shas dina.
Can everyone see?
Sig do esa sangme.
They have the force of gravity on the ball by Earth.
Tadi la shuk chi khartun shasna se khole ithin shuk ditun dos polo gana.
They have a force of friction acting on the ball by the air.
Ani shuk chi khartun shasna thanda darshu jura lungi darshu di polo lagya di ditun shas.
But they also have two more forces.
Digala yangyo ani shuk ni dos dina.
They have the force of Stamatis on the ball and the force of Bryce on the ball.
Ta shuk ni dikhare shalana chik di polo gala Stamatis ki shuk gya di che chik di ani Bryce ki polo di kan shuk gya di shuk ni ditun dos.
So the only way for Bryce and Stamatis to be exerting a force on the ball at the same time would be if we were like this.
Ta di shuk ni tun ra chik Bryce ki gya che chik Stamatis ki gya tun do ta dende yo remove dinang she chyo ina nedang dende chi chag res Bryce da Stamatis ni ga shuk gyar la ra dende ro shtung res
Right?
dende ros nedang de.
So it's very tempting to put the person that threw the ball into the diagram.
Ta kyanzo midi khadu na di khar polo da nyam do thidi dos remove de handa di.
But the question you should always ask yourself first is what objects are interacting with the object you're concerned about?
Ine chuo thangbo di kiranzol kharit susu kharit tang gugu yor lawa na ta ngobo jik thol thigi yora di ngobo shemba kharit da phenju dewa chagi du di samlo ne sha gugu res.
Anybody else have a drawing they want to share?
Ni remote jinda na jik tuen US shemba ruba shemba.
I have to explain this.
Okay.
They do.
You go ahead.
Okay. So in this diagram, this group has two different kinds of arrows.
Ta remote di nal ta wa na ani da di menda wa ni tuen shas.
There are these arrows that are labeled as forces,
Shuk chi kharit tuen shas wa na de la tuen shas da chi ki kharit tuen gud lana shuk tuen gud de re shas.
and there are these arrows which are not forces, but which are curved arrows that represent the motion and the speed of the object.
Ta da sheba shtuen do di ki shuk chungu yo mares khunzu gi thanda ruha su di remove na di khar chungu la na ngobu di yogu chi se gi thanda chojora an thang na shi ngobu di gi gyokse di tuen res.
As the object moves up, it slows down, so the speed is smaller and smaller, and then it starts to speed up again.
Ngobu di ya yu be kapsu thangbo yogu che di yobu che wa che anjel thero du res kang le di an de ne gang ni ma sa ro di sa kapsu ya gyokse di gyoru du res.
But the force on the ball by Earth, the gravitational force on ball by Earth, is the same here, there, and there.
Ina ya tenshu jura se kolegi polo diga tenshu gya jo di ne khawa imba na polo di de yo ina re sangma chikba tön res.
Did I explain that correctly?
Tishi gya jo di khan zo isam zo tharan reves tagda reves.
So we noticed something very surprising.
Tang zo hang san roji thunang le swas thanda thunang chung swas.
The force diagram on the object is the same, whether the object is going up, whether the force diagram is the same whether the object is going up, or it's going down, or it is moving in an arc. The force diagram is the same. There is a single force, and that is the gravitational force.
Ta tanda ngobo khande ji bane tanda ya yugdu I binary ma sadu I binary tanda shugiri mushti ra shugiri muchik res ya khogni yugra ya tene pha yugdu gala di khogdu da di du ya shugiri mudi chik pa chadu res ten shuk chig res dini ten shu res.
So this group clearly clearly spent a lot of time in art school.
Ta di remote la ruga di tuzu shu tang ya sare seo tungu dostina.
So this group has the force of gravity by Earth,
Di ruga di kharten shalana sei khole thishu di tun shas.
and they added the force of the air, the resistance force, the friction force of the air.
Ani chukchi kharten shas yo ina tanda darshu jora polo di gala long di gyawa di tun shas.
So in this diagram, is the ball being thrown from Stamatis to Bryce or from Bryce to Stamatis?
From here to here, or from here to there?
You mean they can't tell who's who?
Ta polo di tanda nedan kharten la ina khorani gi pharla lewa chi di tun res. Yana Stamatis ki Bryce la yug dewa chi yana Bryce ki Stamatis la yug de khorani gi pharla tun shas.
Which way is the ball going, do you think?
Ta khorani gi pharla yora polo di chok khajo dugu yo do samgu dos khiranza. It's going towards this side.
How many people think this way?
Ta khajo de dijo dugu yor sam pha dugu yor sam nge khajo yes polo di.
Oh, yes? How many people think this way?
Polo dijo dunge yor sam nge khajo yes.
What about the people that drew the diagram? Which way is the ball going?
Ta remote thinge je ra di ruga khandi chawor polo di chok khandi dugu yores khajo.
So they say the ball is going this way. So the people that drew this are saying the ball is going this way.
Ta remote thinge ruga jora kuran so kharshi lana polo di phajo dugu yor lan she sons.
And the force that is acting in the opposite direction as the motion.
The friction force, in this case the air, is acting in the opposite direction of the motion.
Ta polo di yogu chisa cho di phajo chadera di gi do be khari yungor lana shu di anda darshu di res lungi polo le kya wadi.
If I had magical powers and I was able to make Bryce very, very small,
Ta mixe shuk do yo ainas ani price chunju shu su tu yo ainas ra.
and if he were on the ball,
If
I was staying
yes,
on the
okay,
ball.
okay. Kesi Bryce ani chunju shu su ni polo di gang la shawai ya shawai nas ra.
as the ball would be moving, Bryce's hair would go back.
Ta Bryce di ga shahara polo di gang. Ta polo di inde lung na ya yu wake up su khachi la na Bryce kita din zu ya gap chol dugres.
Because the air would be hitting his hair.
Kais na lung digi di tal thu de res.
So the air would be pushing that way.
And lungi biye jora di chok haru la na sujo cha de res.
So good drawing.
Good drawing. Very nice. We discovered, though, something surprising. So, if the ball is moving up and the force is down, the ball slows down.
Ta zo han sa engineer res tanda di pesun shasa ball polo di ra. Polo di ya do wake up su and shuk ji res di ma shuk di ma yag res.
That was something that is the same as our skateboard situation.
Ta di nedan di khari da chi pa cha de la na onjo tanda kholo yo skateboard ya di chego chimba di da nedan do cha de res.
When Bryce was coming this way and I was pushing him, he slowed down.
Bryce Pajo Droe Kapsu, Stamatis Kika or Indu, Katire, Korangi, Jose di Teru Teru Duas.
When the ball was going down, this is the same situation as with a skateboard when we were pulling on the skateboard and our friend was speeding up.
Di Nedans the Apollo Ma Droe Kapsu. Di Karida Nedanchik Pachagir Lawana, from the skateboard of Michik Ma de any Shimbaji Tengua, di Tewe Nedans the Dida Chipachadu, Res Ma to do.
The same force diagram, but different motion.
The Shugi remove Chipachadu, Res Niga. In a Yogi di Karirlana, Kebayo Res.
And here we discover a third situation. If I neglect the force of the air, let me pick a point up here when the ball is up here. At that instant, the ball is going that way. And there is a force that is pulling it down. And it makes the ball turn. And the earth is pulling down, and it makes the ball turn. And the earth is pulling down, and it makes the ball turn. And the earth is pulling down, and it's making the ball turn. So here is the first example of a situation where a net force is not only speeding something up or slowing it down, but it is also causing it to change in direction.
It changes its direction, right? The Jora Teru Kitchen machine, Tanda Mobo Jora Digi, Kacho Jura, this will rest.
So a net force is responsible for speeding up, slowing down, or changing direction.
That Zangshu Lajura, Digi Shugin Hatir Lana, Chik the Gorotanche, Terotanche, Tanashi Kacho Jure Juramobo, Diti rest.
So why don't you put this down? Concentrate on being stable. I guess not.
I had to turn the wheels.
Yeah. So with forces, we not only speed up or slow down, but we also change our direction.
The Shugi, Gorotan, the Terotan Chibu Maimba, Tanashi Kacho and Juatangu rest.
So during tea break, we are going to ask you the following thing to do.
Maybe when you come back into the room after tea break.
When you come back, yeah, so we have half an hour.
8:30. We have another hour. Well, then bring this up there.
Okay.
So we already did. We have a bowling ball.
Ta thanda di polo di yo res.
That's already moving.
And we want to change directions.
Krai khajo gyue gyugo res ngi.
So when you come back from tea, we want you to try and see how you can change the direction of a ball that is already moving.
Ta soja percent jel chu phegra di jel khiran zungani na res har na so na polo di yogu chewe kapsu and di khiran zugi khajo gyurgo na khari chi gu dula jura di res.
And how can you make it move in a circle?
And thanda shi khiran zu yogu di thanda yogu chi du khajo gyurla ra di ni polo di kora gyani doye yo de ji khandes chi du res lan khiran zungani na res.
Which direction would you want to hit the ball relative to the direction the ball is already moving?
Ta khiran zu ida ya dungura di polo di yogu chewe kapsu and di khajo khane ni dungu me di khiran zu tunan chi gu res chi.
Okay. What questions do you have so far?
Ta thanda badu khiran zunguni tiwa and US thanda. Ta thanda badu zinda tira tiwa US. Okay, here's a question. So there are three laws of Newton, right? There are three laws of Newton. So is it because we are saying this is first law of Newton's first law, second law, third law? We see that it's a kind of series. So is it because of like the laws are made because after the time Newton discovered? Is it according to the time he has discovered these laws? Yes, or when you teach in the class, so we felt that you taught this third law first. So what is the reason behind that?
That's a great question. The sequencing, the numbering of the laws is the same as comes from the numbering of the laws that Newton gave in his book, which was published in 1689.
The Newton ki thep chitam res chiktong thukya geji girgula tam res thep dira temple chires digap so ani Quran gi trodang jora thangponi wasumbalan til pa beni ning disha res.
We decided that it is easier for us to start with the third law.
Ta ngonzu gi khari thaju chior law ina gochuk du gala sumba deni gochuk na lela oj thon res.
Because the third law allowed us to think about what do we mean by the word force.
Ta sumba dingel thidu gala digi khari tyungir law ina thangi shuk la jora di khandre lan di gal samlu ta res.
In daily language, we use force, strength, power, energy to mean similar things in daily language, but they have different meanings in science.
Tangazo chida gyundegi thange pheju chidu gala shukla da top shu do da niba da di sangma chik do pheju chigyo res ine sering nala dindu sangma khwa loga chha res.
Without having negotiated what the word shuk means, we could not start with the first or the second law.
Ta shuk le thangi jura di goma sui bodu ani tentim thangbo de niwa drotu mares.
And I will have to tell you a secret.
Kenan zola sawa jima yes.
Because you are very, very good students,
Ta kenan zo look to yaku shuros.
I do not tell the secret to all my students.
Tangi look to someone like sawa di shigi yo mares.
Although this is Newton's first law, the way that it was written by Newton, that is not how we understand Newton's first law today.
Ta Newton ki tentim thangbo di thisha jo jara di thanda ngaran sugi pheju chinali dinde jil lagudulan go sugura di do thiyo mares tidang di.
You remember that we left the first law as the last thing for us to negotiate.
Kai sana ngaran sui thanda pheju chindanal da di tentim rodugala tentim thangbo di thama shai mas.
So here is the question. The way that the two laws are stated, it seems that the first law is a consequence of the second law.
Ta di deshi yadan ta oina ta dugala di khari ki dumde do da di ki jela di lejo do thungu res.
The second law connects the acceleration to the net force.
Ta tentim niba di khari da khari thugu se oina nyurne di da sangshu di thugu res.
Well, if the net force is zero, the acceleration must be zero.
Ta kesi sangshu di lego rimba ina nyurne di lego lan shigi res.
If the acceleration is zero, then the motion is not changing.
Dila duta nyurne di lego re la oina jose jura di gyo du yo mares.
And there are two kinds of not changing motion.
Dila dugala gonda yogul dile gyo yo mares. Ani yogul gyo yo mar le dugala ni yo res tanda.
This is one kind.
Chik di yogul la gyo yo mar la du rigni yor la ra chik di chag yo res.
An object at rest,
Ngobo de sorne de yo kapsu res.
or an object that moves in some direction with uniform speed.
Neda niba di khari cha yor la oina ngobo di yogu chig yo res khajo chigla. Dine yogu chidugala jose chigran du da bi res.
So then the first law, as stated, seems to be a consequence of the second law.
Che zanta digi jela laura da tumde do laura tendim thangbo de niwe gi jela tende do ji cha de res.
But if that is the case, then it should not be a law because it is a consequence of another law.
Ta dende imba ina an tendim gugu yo maras dila do chigi ta tendim chigi tumde do ji cha de ras de. Ta shugin la na tumde do tende do ji consequence la na de do ji.
The way that we understand the first law is the following.
Ta tendim thangbo go suye jora di khandes ko chutur la na tendes ko chutur res ta sherishma.
Measure the acceleration of an object using speedometers.
Ta ngobo khande ji na digi thanda nyunne di je gugu res ra di je la pheju khar tang gugur la na jose jel che ju adi pheju chi res.
Measure the net force using force meters, like the meters that we put together.
Thanda changshu yo di je la ngazu khari pheju chi la na shuk jel che ngobo ju yo je di pheju chi res.
If the speedometer is either zero or unchanging,
Ta thanda jose jel che ju yo di la ishlo go yo angi khaju li yo me kesi lego rimba inas yana jo du me wa inas angi di.
and the net force that you get from your force meters is zero,
Ta thanda ngazu shuk jel che gi yo je ju ra dine ni ta wa na dina lage lego rimba inas.
then that is a good system of measurements in which you can apply the second law.
Dila du ta thanda malaj do de ra dila ani khirangi tentim ni ba di ya jar thu yo res ta ta.
Let me give you an example where it is not a good place to apply the second law.
Ta tentim niba thanda di nedang dila jar thu re la ra ta jar ma thup se nedang di nge she was ma tentim niba di.
You have all been in rickshaws.
Ta jo thanda auto dindina le dronyung ras ngan sama motor di.
Sometimes from the rear view mirror of the rickshaw, the driver has hung some beads or something.
Ta thanda rickshaw na du kala khalo ai surla di shego shayu ya shego wala thanda ri do de thenga do shayu da khon jogi tinde khashi changni shayu do as khon jogi shego la ta shayu do tinde.
When the rickshaw is stopped, the beads are hanging down.
Ta rickshaw di ka du kala thanda thenga do ri denzo ma changni sha shayu ros.
And there are two forces exerted on the beads.
Ta thanda ka du kala thanda thenga ri jura di kala ani shugni ge res.
The gravitational force pulling the beads down,
Ta thanda ri dila chi khari urla na shugni ge ra shugchi kharla na thenshu di res thanda ri diga thenga ri diga.
and the string force on the beads pulling them up.
Anchi khol chang shirla na chang sa kuba di cha de ra kuba digi thanda ri di ya thengi res.
So the net force is 0.
Dila du gala changshu di khaju chagor lawai na lekor res.
And the beads relative to you sitting in the back are not moving.
Ta thanda gangla ri thungu ra keral te ni tawai na yogu chigi yo mares.
So that is a good place for you to apply Newton's second law.
Le ta dende ro ne dang jim bai na tentim ni ba di jare takta stigi res.
But the light changes. It goes from red to green.
Ta motor di khare dogo me te ta to yingi juya mao di kisi hopto me jangu chawai nas.
And the rickshaw driver starts to accelerate.
Jangu chana ta ra ni khaloi gochugu res motor ta.
The beads now move back towards you.
Ta riri den su khar chirla na gang chang shagyu di kiran chola ya li roas.
And as long as the rickshaw driver is accelerating, the beads are going to be hanging at an angle.
Ta motor di tang de gap su khalo di ta thanda riri chang shagyu jora di kyo de yo rosh di roas and surgu ta ina surgu yo chagyu res di.
Here is the roof of the rickshaw. Here is the string, and here are the beads.
Ta rickshaw I thod di chagyu res di kuba di res and di wala riri jora di chagyu res.
And here are you.
And di kiran res.
And the rickshaw is accelerating that way.
And rickshaw di nyun di ta khajo tyong bai na di res di jo.
You are inside your rickshaw,
Kiran rickshaw na lu shön res.
and there is another monk who is on the street.
Ta langa la kusho chigyo res chilo la ra.
So the monk on the street sees the rickshaw with you and the beads accelerating this way.
Ta langa le ngi kusho jora korang kita du khar tungur la na rickshaw da da riri jda gi riri di da ni kiran nyun chota wa na korang gi thondu nyun di khajo di jo tungu res.
So the monk, so this is Tashi, and this is Sonam.
Thanda rickshaw na shönge di mingla ta shi shagi insra chila yunge kusho di ani sonam res.
So Sonam and Tashi draw the same diagram. On the beads by earth, and this is the force on the beads by the string.
Ta shu gi remote yo na tashi da sonam khorani ga remote chi pa thires di shu di khar la na thanda gigri ri ju di gan la se khole then shu di res di gan di gigri ri di gan la thanda kube gi then shu ju ra di shu di cha de res.
So the sum of these two forces, because they are not pointing in opposite directions, cannot be zero.
Ta de shuk ni digi chang shu de dombe shuk di ta waina niga khajo loga cha de dos di indu gala legor chagi yo mares dombaina.
Sonam says, great, non-zero net force, and the beads are accelerating with the rickshaw.
Ta sunam gi legres ta ga reshas chang shu ta waina lego marwa di indu gala ni riri thanda gi riri di nyun khajo di ju tyong duslani ta da res legres sonam gi.
So Sonam says, Newton's second law is good.
An sonam gi kharishigir la na tentim Newton gi tentim nyo di yabu dus legres.
But Tashi says, not zero, the net force is not zero,
Tashi kharishigir la waina chang shu di lego mare legres.
but the beads are not moving relative to Tashi.
Ne tashi khoran tu ni ta waina thanda gigriri di yogu chigum indu legres.
So Tashi says, the beads are at rest.
Tashi khar legirla na beats di yogu chigum du sonne resha la jura di shigres.
Relative to him.
The khoran tu ni shewainas.
And so he says, I have a non-zero net force, but the beads are at rest relative to me.
Ta tashi khoran khar shigirla na ngaran tu ni shewaina sangshu di legor marishas yine thanda gigriri jura di ni sonne reshas lan shigres.
So an accelerating rickshaw, inside an accelerating rickshaw, is not a good place to apply Newton's laws.
Cheza Newton gi tentim denzo ta thanda riksha di nanglo le shweni ta tentim di ta waina di takta madeva thongures.
But relative to Sonam, there is no problem with Newton's laws.
Ine sonam tu ni shewainas Newton gi tentim denzo kangi khegush thong mares.
So the first law then is a law about which places, what are the conditions for applying the Newton's second law.
Ta Newton thangbo di tentim thangbo di khar thungur la waina ta nedang khandesh du la jura di tentim niba di kho jargum du la di nedang la ral gu yores la jura di ta go khejum chag yores.
I know that this is a subtle idea.
Sorry.
I know that this is a subtle idea.
Ta di ting sabu la ora de shu cha de yores ta nga ha gu yores di.
But you asked about the sequence, why we chose that sequence, and I felt I should be honest with you.
Ta ine kheran chu gi ta di khorim di khandesh rela ni thio di tang ros an chezan ti ling gya yins.
Any other questions?
An thio shimba yores. Bryce the stammeres para UA dila. Sangshu khari race laura. So when his question is when the ball is in between you and Bryce, so what is the net force on that ball?
The net force on the ball between me and Bryce, it is the same as the net force here, there.
The gela itio di kosa polo di you surprise the stammeres parala. Sangshu khari race. Ani stammeres ki link khari gyasyo na polo di ne khawa yo bai na de ina re sangshu chik par race polo diga. Okay, so is the net force this gravitational force or there is some other force?
So if we are neglecting the air, then this is the net force.
Kesi lung shuk jura lung di chime tang waina ani changshuk thagrang chagyo res thengshuk di.
If we are not neglecting the air because we are not throwing a tennis ball but a wadded piece of paper, then we have to include the force, the rubbing force of the air.
Ta kesi nganzo polo chunga ji che digala shuk ro ji tumni tang waina ta dila ani nganzo lungi shuk jura di chibe tang mares nedang dende ji sha waina.
So, yes.
Polo da chadudi. Korani jitse chikpa res ra chikpa member ina ani sai tenshu chikpa ina ani ale jise le kheba yo ina tenshu le kheba du res so lung mesa di ra so when you have like sucked out all the air from that chamber when you use that example of feather and ball so there is a differences in the weight of these two objects. So it means that the gravitational force on these two objects should also differ.
That's right.
But both these objects fall at the same time on the ground.
That's right. So the gravitational force on the ball is different to the gravitational force on the feather.
Res kailana tanda tenshu jura polo gal tenshu dida ani chadu dia tenshu jlira dinil khebar yo res.
And yet somehow the accelerations are exactly the same.
Ina tanda nyurnu jura di khande ne korani la chikpa yo res ngobuni dila.
And so that is what is the same when we're talking about free fall close to the surface of the earth.
Di nganzu tanda ranglung la jura se di tanda ngogal ma sa di keji shidu ranglung di keji shigi res.
I think one thing that's very important to remember
The nedunji samba na shagwe kechumbu chagi res.
is you always want to ask yourself what objects are interacting with the object you're analyzing.
Ta kirangi tunan chigo so ngobo jura di ngobo khari khari da phinsu dewa chagi du di samlo na shai kechumbu chagi res.
And it doesn't matter if the object that you're concerned about is at rest or it's moving or its previous history or its future history.
Ta
You really
ngobo
need to think about its present moment.
ta ngobo jura kiran tunan chigo sa di korangi lo yu da maung ba khari chigi me da dinde gal samlo ta yo mas thande nedang lo korang khardo yogu chigdu yana sorne resha di ta hu res.
And if you do that, when you draw these diagrams, they will come much quicker.
Chezanta maung ba da deba dinde gal samlo ma da na nedang thande rang khari yo me jura di ngobo di gal tunan chini thiyo na rimu di jogo thi thu res.
I think we have time for one more question.
Oh, that and that thiyo chikla thuju dus thiyo chik ta na.
Chado namka yu jamata roje me ko yara. Roje music temu ji ba ji music temu mani roje me ta ma sa cha ma sa music temu
Jose tempura jose chik.
Jose temu mani sa ji me ko kira. Ani sai teshu ko ke de ba. Sai teshu ki jida ma zo ke kaze shu ji ti u zama mo ji ge ani shu ji mo she ji ga ke ba na. Ani dosho shu ji ko ye le ba. Di sai teshu ro ji chado ga ke bi kara ani ti dosho shu kare ja de.
Tanda polo gajire changdo gajire. Okay, if there is any object like this ball, for example, so when you throw it, there is a gravitational force on this earth, right? On this ball, but you have already mentioned that there is an equal and opposite force on that. So what about that force?
So you're, just so I understand the question correctly, you're saying when you throw the ball up in the air,
And it moves at a constant speed.
right?
There's a gravitational force acting on this ball.
Right.
So what about the opposite force, which is
So there's the third law, Newton's third law, pair force for the gravitational force of the earth pulling down the ball.
the Newton ki tentim sumbe shisung shao na thanda tenshu juro dila ani dobe shuk juro lagi was
What is it?
di khari res the force exerted by ball on the earth.
Right, it's the force on the earth being pulled up by the ball.
Dila du gala shuk di khari lana se khole gya ro se khole ga gya de res thingi su cha de lana polo di cha de ra di res.
I want to maybe share one interesting tangent.
Ta yang gyo di dan dewe chik ne dun ji share yus.
If this is a distant star,
Tanda nga zu di se kola ni tharung bu yoy kama ji imba inas.
and astronomers look at a distant star with a telescope,
Ta karchi ribo wa din zo khunjo gyangshe gyu ni tagiro kama di tagires.
they might see that at one moment it's here, then a little bit later it has moved over here, then it's over here, then it's over here, then it's over here, then it's over here again. We say wobbling, it's going like this.
그런 저 양신 있다 되도 그런 저 체리버들 저 가르 통구를 나와 있나 까마디 요구 지단 줘라 된대신 요구 지기와 통구요레스 양식윤이.
And that's because there's a planet that's going around the star, and the force that the planet is exerting on the star is making the star wobble around.
디 된대신 요구 지기요라라 가르친 지기요를 나와 있나 델라 사지기요레스 디 사디 kengi 디 까마디 요구 된대 지기요레스.
This is the Newton third law of force pair between the planet and the star.
따디 뉴턴 기 텐딤 숨바기 단데 슈기 차라죠 슈니 니냠도 니기를 라죠라 찰 니기를 코라니 파르디 차요레스 디 kengi 아니 디 까마디 요구 지단 된대 지기요레스.
And this was the first evidence that astronomers had for other planets and other solar systems.
ता कर्जी छेरी बाइदी सन्ये छुंदु गला अनि ता सा शंबादा थंदा नि निमे किम यु शंबादा दिनरे नि रेस्पोंस.
So this is Newton's third law helping us figure out, is there life in the universe outside of our solar system?
Life
Life.
ता ngalजुगी थंदा जिगदेंग हमगी छिला अनि ता दि तेंटिम सुंबादा दिनरे युनि अनि छेसो योरवे लाजोरा जिगदेंग हम शंबाला दि छुवा दिलि रेस.
Because if there's planets around other stars, there's a possibility that there is life on those planets.
ता सा शंबा दिनरे ला सा शंबा यो केंगे अनि सा शंबा दिगल छेसो यो सिगिरे लाजोरा दि छुवा दिलि रेस.
And the same thing happens in our solar system. The planets in our solar system are sun wobble.
알았어. 간다로와. 얘나 짜도 키로치 제가 이 남다른 사람들은 그냥 야생이 짜도 보내라고 봐. 봐. 아기 도서 사이 페이지도 도서 슈 짜도 슈 페이지도.
No.
이 인바이는 때나 짜도 이 사이 올라다 양다 하자 리미지 다 사이 올라 페이지 많이 비켜 길어야 짜도 보는 제시 되어를 키로치 제시.
Okay, so
कैसे तीन में बना रहा अरे चारों तरफ यार है मुझे मेंगे तुम दूसरा बोला कि था रिंग छाता नहीं चारों तरफ की चीज़ आने से में बना अरे यार की इशू दे चारों योर लाया अरे काश बोला
So his question is, when there is a weight, an object of weight 1 kilo object,
Yeah.
and when it's near the surface of the earth,
Yeah.
so when you put this object much further away from the earth, and with tenshu yo mare la ra mesala. So when it goes beyond the gravitational pull of the earth, when that object reaches that distance, tharinglu digas le du koral jise kilo chik yor west ra thiwa. So does it weight 1 kilo over there?
Can I do that?
When it's at a distance beyond the gravitational force.
So one way to think about this is if I was to go to the moon and I brought a scale,
Tat pe shaw ina ngara tawa kal dro res ra ani jise kya diyo res
and I stood on the scale,
di jise kya gal ngai digal za res ra
the reading on the scale would be much less.
ta jise kya di yoji dil tai ra di tadu gala namju le nyunga thungu res kilo di.
In fact, I can go to each of the planets in our solar system and I will weigh a different weight.
Dila du sa minro ru thanda dawa she sa ya sa shimbala draw inas ya jigo di jise ta ina jise logo thungu res.
Likewise, if I played catch with Stamatis, this gravitational force on the ball, this part would be the same, but then we would have to change Earth for Jupiter or Moon or wherever we were.
Ta thanda polo yuwe jora korani pharla di thanda sai khole ga indu gala tenshu di sai khola gila ni ta gya shera tang sa phu do jil draw ina di rangja di re ne gya di loga chagwi ros dela ani sa phu ga imba ina sa phu la ni yo tang gu khigres.
The more massive the planet, the stronger the gravitational force.
ta sa khari sa khoran la ral go res sa khagas ki sa di do se che hoina digas ki thenshu che res.
But as we get further and further away from the planet, the strength of that gravitational force decreases.
Ta thandang anju sa khari she de lan sei khola dirwa sei khola ni khagas kyang ta ringwa do hoina digas ki thenshu di ma cha du res kyang ta ya tha ring ru du thenshu di cha go res.
It never goes to zero.
Le gor cha ma res ne thenshu di.
It just gets smaller and 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 smaller.
nyungru ma cha jora di dur ma do le gor cha ma res.
So you can think that Jupiter is pulling on me right now.
Ta pe shawainas ta ngala thanda sui thendior lana saphubu gi thendio chashas
And the moon is pulling on me.
ani daga gi thengyo res
And the sun is pulling on me.
nimai thengyo res
But those forces are so small compared to the force of gravity of Earth.
thengyo yor de ine tenju gi shuk di chunju shu res sai khule shu de durwaina.
Can I add one thing?
Ta yangyo nembe chik she yes tamaris.
So the question was asked in terms of kilograms.
Ta thiwa di thanda jise gal kilogram la thesonsra
Weight is not kilograms.
jise la di kilogram chagi yo mares.
We defined weight to be the gravitational force on an object by the planet.
Ta jise la jora weight la thani khande jil shagir la aina ngobo dila ta sa khande ji imba ne digi thenshu khaju gya ime jora dila ani jise la go res.
So yes, the reading on the scale would be less on the moon for me than it is here on Earth.
Res ani thanda jise kya gi yoje juya dikhini dawala kya waina stamatus ani sai khola da durwaina jise di nyunga thung res.
It would be actually 1/6 of what it is here on Earth.
Dila dugala sai khola la khaju imbe jise jura di dawala kya waina thukja chik chagyo res phagil kya du.
The easiest way for me to lose weight is to go to the moon.
Jigo cha la jora del ngonju ke ji ya jigo cha le du lela shu khari chagor la na thablam chi dawala dun jigo kyan digyo res.
But mass and weight is measured in newtons.
An thanda jise la weight la shu da di jelche ta che jora di khari na gyawor la na newton na gyagyo res.
But if Bryce and I push each other here on Earth,
Ta se khole gala Bryce na stamatis khorani phachu bi bainas.
Bryce will find it hard to accelerate me.
Ni stamatis la ma unit teora di ani Bryce khoran kha churgres.
Because my mass is large.
Khai sana ngarangi stamatis ki dose di chewayres.
So even though I would have a different weight on the moon,
Dawala jise loga jiyo bayina ya.
Bryce would have exactly the same hard time accelerating me on the moon as he has here on Earth.
Ta Bryce thanda dawa nacha shawana jise di ma chagir lawara stamatis khoras. Ine ya Bryce khorangi thanda shu gajora sai kholal shu khande gyaw nashi ya dawala do enege shu thagarang gyaw khi res Bryce ki.
If he were to kick me, his foot would hurt exactly the same on Earth as on the moon.
Ta Bryce ki stamatis la dongya shu ainas khagas ta dongya shu se khagas shu aina di nagra di na di sai kholal khagas na nashi dawe gan la dongya shu aina thagarang jan negres nadan.
Because my mass is the same on Earth as on the moon.
Khai sana stamatis ki dose dita aina sai kholega ina re dawe ga ina re chipar res.
The number of kilograms will be the same on Earth as on the moon.
Ta kilogram lan kilo ta ja di ani sai kholega imba ina re dawa ga ina re chipar thung res.
Even though the reading on the scale would be different.
Ina ya di thanda jise ta ja di ta na la loga imba ina chipar res dose da di kilogram di.
And Newton's second law is expressed in terms of the mass of the object.
Ta Newton gi tentim niba ji do di ngobu gi khari da dewe shigo la no ngobu gi dose da dewe shigi res.
So an object has the same mass everywhere in the universe, but experiences different gravitational forces.
Ta ngobu khande jim baina digi duse ta waina sak hol sha waina duse chikpa res ine ta thenshu di kheba dugu res.
So let's break for tea, and we'll see you after tea. We will bring out the ball, the bowling ball, and the mallets. And we want you to get the ball rolling just a little bit, and then ask yourself, how do I need to hit the ball to make it move in a circle?
Ta soja person phigra thanda phesa jela ni chilola polo di dan tho chunju sta dikhini ani polo di yogu chiyo gapsu anjo tho di shu song sa di shuni polo di gogo chini dre hande su du di ta gu res ani shu che khaga shu du di kiran zung ni ta ji cheres.
And we will do this with small taps, small forces, and frequent forces.
Ni shu geira shu di gogo che ine ni ni shu chimbu shu mai ba shu chunju shine ani gogo shu ga gu res.
Okay.
The speed of the ball is not changing that much. Right? Why? The direction the ball is moving is changing. But the speed is not changing that much.
Ine
We're going in a
jose di
circle.
kora gyadu gala polo di ani jose de jo shira rumun doas.
Ask him. So this is a different experiment here. Ask him to make a circle. Can you
Kelo
make a
gogo
circle?
gogo sero shida sadi. Gogo tangda.
A circle. A circle. Let's try a circle.
Gorgor se tarsi shida. Gogo.
So you can imagine this is like the moon going around the earth.
Ta kiran so dinde samlo na shana di ras di dawaji imba che se khole tha kora gyan dugi waj.
The moon moves around the earth at a constant speed,
Se khole tha la dawa di yugu chidu gala an jose chik la korgi res.
but there's a force always pulling it towards the earth.
Ine shuk ji res di dawa di khadu na zamling cho se khola cho thingi res.
But it's not a giant hammer.
Ine pai shuk di thanda ngajo da thoa di mares.
It's the gravitational pull of earth.
Pai shuk di khari cha de lana se khole then shuk di res.
Let's go inside because not everybody can see out here,
Ta del ta du sangma thong thong min da che za da ngaras nanglo jogos.
and we'll talk about this some more.
Di thola da chodur yangyo na isindana.
What did you guys notice outside when you were with the bowling ball and the hammer?
Polo di da thoa shuni kenan jo tajin nang ra che go di. Dil ani tunang khari chung sos. It circles.
It made a circle, but how did you have to hit it to make it go in a circle?
Ta kora gyur la ra. Kora gya di khandes kya thu dos. Khandes shui is polo di. Hit from the side.
Hit from the side. But you know, if you hit from the side, you think that might make it an immediate turn to the right or to the left.
Ta thani shua ina hopta me yana ye cho yana yuen cho du dos polo di. Yes.
But it didn't do that.
Ne ende chima sos.
You know what I'm saying?
Seo cha sos ta thanda di.
It didn't immediately, you hit it in one direction, it didn't stop moving in the direction it was moving and go in that new direction.
Dila du gala shu du gala ani khabdu ro dig min dos shu du gala cho shamba jil du dos sawa jil.
Right? It didn't stop moving in one way and just turn and go in this new direction.
Dila du cho chilo mando che kyo ni cho sawa jil du dos.
It made a small adjustment.
Dila du tis chi gyo ta res.
And every time you hit the hammer to the ball made a small adjustment.
Dila du shu den re la ni gyo tis ro dig res.
So you were actually never hitting the ball in the direction you wanted it to go. You were never actually hitting the ball in the direction you wanted it to go.
Polo di dre di jo drogure samejora di rang la kerangi chodele shugu mares shudu.
Otherwise, if the ball behaved that way, you would make like little squares.
Di dende chiwa ina ani polo di drodang di khande durla na drodu gala ani tushika hama sugres.
There was several experiments when the ball was moving in a sort of a constant speed.
Dila du taje shidu taje mangbuna la polo di kora gyagura di ani jokse chigrang la gyagures.
The speed of the ball was not changing so much.
Ni polo di jokse di jo shira du yo mares jo chimbu shu yo mares jokse chigrang do sto di gyures.
But every time you hit the ball, you were applying a force.
Ne kerangi to di shudu kazu shuwa ina di shujo di kharela na shu gyagures.
If you apply a force, that means you're applying an acceleration to the ball.
Ta shu gyagyor la du kharla gorla na polo di la nyurne ji thegyures.
And so one of the important ideas in Newton's laws is the idea if it's at a constant speed in the same direction,
Ta Newton gi tentim la shawa inas ani jokse chigrang la du yo ache ni shu thara in bainas
the net force is zero.
ani kyondom shu chang shu jora di le gores.
But if you change the direction,
Ine ngazu khajo di yo inas
then the net force is not zero and it's accelerating.
an khajo di yo tang oina ani chang shu di le gor chang mares an che jang ta ngobo khari imbadi ani yo du yores jokse dila.
If you didn't hit the ball at all, it would just keep rolling away. If you did not hit the ball at all, it would just keep rolling away.
Kisi kerangi shu me oina polo di yugo che go zura ko babritin do di res phabodo.
So one way to think about this is that the ball, every time you hit the ball, it's accelerating towards the middle of the circle.
Dila du kerangi khazu shi oina thyanan shi yune theni polo di korarang gya di res.
Does that make sense?
Seu cha suesi.
Did everyone get a chance to see that? Because I think many of you did, but did anybody miss that outside?
Ta thanda chego takje ji chiso di changme si suesa khainan dusana khashi si changme sira.
Any questions about that?
And di thola chiwa US. Yes. One question. He also has a question.
Tata phajoni sigu chirwa again number ni nga tsen de train man de ro ta te khon number ni le ni chi tra him ba cha yo chi so na him ba cha yo ta tra shi gitni magiti sho chi le dong ya te de ndo chi ta ndum da chi dong sro dong ne de su ko ra je du ani do ti tha ni shi te ni chi chung chi man ro jin dos ti ni ta lo zong ta cha ya ba ina ro so na him ba 아니 콩게 동동데 빼 째서 그런 족부 휴지 동니 이나 공파디 가서 도리디 비님 포폰 로야티 대보지를 임발라 이나 코랑베 휴지 티거도스 이나 나티드니 이니 가르텐소세나 나조 사이 콜란데 니 코데오르 코로코로지 코데오르 세도 티 코야티 니 상춘이 야야메 바타코 코디야티 동니디 스웨데 타코
So we have seen this experiment. In this experiment, like when Tashi hits the ball slowly, it circles. So likewise, when Sonam hits it harder, like it spins, but it makes a circle, but the ball itself spins. So likewise, when the Earth rotates around the Sun, there's a force which is making the Earth circle around the Sun. So what is that force?
The question is, what is the force making the
Earth circle around the Sun? Yeah.
Well, what is the question about it spinning?
아니 polo khorong khorgu darang gor shuk chumbu gyawe kapsu an polo khorong khorgu dosung ra dil thiwa US tad say khore jora gele thiwa he'll draw it.
Okay, draw it. I think he was talking about when there was one experiment.
Chopo tangi jaro ko. Chopo tangi ni ko.
When he hits the ball hard, it moves this way.
So that wasn't a matter of hitting the ball hard. That was a matter of how he was hitting the ball.
다 슈크첼로 가가스 주게메디 케바요 마레스 칸데스 주게메디를 케바 두요레스
He wasn't instead of hitting it straight on, he was hitting it on the side, and he was making it spin.
탈레 슈요레스 아기라 슈크첼로 케바 두요 마르 슈당을 케바 두어 탈레 슈드 아니 폴로 디랑 코랑 코르고요레스 랑고르디 탈레 슈드
공 드린 거 휴즈네.
So instead
he
of
hit it
hitting
at the front he said
yeah, it's hitting in the front.
다시 이거.
So if you hit it on the side, you won't make it spin.
탈레 슈아이나 아니 랑고르디 갱 마레스
I mean, directly on the middle. But if you hit it in the front, you can make it spin.
키 랑라 슈아이나 아니 디 랑고르 게스타 폴로 디 갱 마레스 이네 탈레 슈아이나 안 랑고르디 게요레스
And what he did was he actually started it spinning like this.
코랑 고츠도 당보 코랑니 단다 폴로 디 랑고르 게조라 디 게초 손스 안 디젤 슈요 고츠 손스
Right?
로사 아기라
So the other question,
다들 난 기억대로. 그 근데 지야저고 코야저고 딱 밤에 그 너무 멀어. 그 밤에 거도
가르코
처음에 그 너무 처음에 거도. 그래서 사이콜라 동기세는 딱 그때 지역으로.
So there's no stopping, it keeps on moving, right? It keeps on making circle. Likewise, our earth also keeps on making circle. So what is that force which keeps the earth moving?
So you can look to, and Stamatis will probably answer this maybe better, but if you look to Newton's laws, that an object in motion will keep moving in motion until something acts on it to stop.
The guest Stamatis tension course was Dina Harishera no Mobochi Yogu Chigioina, Yogu Rang Chidi res, Ra, Yogu Chini Dedi res, Kesi Shuk Shembachi Makapado, Yogu Chigioina, Shuk Shembakagi Meo, and Yogu Rang Chidi and share res.
This skateboard will stop moving because of friction on the floor.
The skateboards without Holo Yodi. The Yogu Chigio de in a Gagaduas, the Kajin Gagorlana, Tarshugi King Gagu res.
But in space, there's no air slowing down the earth.
In a Panando Chashoina, say Colacordera, the Dodugal Yogu Chidugala, Lunkangi Yomares.
So the earth keeps going around the sun at the same speed.
Chezani, Nime Tala Kora Yagura, say Coladi, the any Josechik Grand Locordi res.
Not exactly the same speed, but for our purposes of humans on planet Earth, it's the same speed.
The Chikpa Takta Relana, the Lish the Marine, and around to get the say Colenta Dugala, Josechikpa Rostungi res.
So there's no force acting to slow down the earth.
Dila do say Colella, that Corejora, di Terotangi, and it shook Shemba Mares.
Or more precisely, that force is so small that it doesn't make any difference from year to year.
The shook Gio and a shook the Chunju Shures, dig any Koran Koredil Keba Kebuji Suyo Mares.
And the reason the earth doesn't fly off and just keeps going off in space somewhere is because of the gravitational pull of the sun.
Ani say Kola di Panang Leduala, Shimba of the Mer, Yap Chung Red, the Dindiora, Dindi Yungu Mares, Loud Red, the Dindi, Kaisana, Koranchi Grand Lopor de Kari King Kurgur Loina, you may Tenshu Jura, dig any Netaran Cordage or the Yungu res.
Newton's third law describes why all our planets are able to stay in orbit and not fly away or fly into the sun.
Dila do say Kola that Samangu Jura, Newton Tentin Sumba, Shizum Droina, Di Tanda Dishi Yadan Chiniani, that Sadin Samba Tata Koran so Kolam Rang la Port the Gurl and Shigi res.
comment or question?
I have a question which is related to that question that he asked.
Tanda Gela Tuach Tansa didn't do any Tuach US Tamatis Koran.
So I have a question for everyone, and it will help us better understand Brysla's answer to that question.
The Tuaju, the Matangi is Tua the Tangsani Kariseru Durlaina, and the Korangi Tua Tangula Bryce Kilangi Gasa, the Lane the Serudures.
So in the experiment that we did outside,
And the Chilol Taji Chambers,
the bowling ball was moving in a circle,
Tanda polo di khordang di khandi khorgorla na gogo khorgu res.
And Tashi was hitting the ball in this direction.
An tashi gi polo di le shugu res. An shudu khajo khani shugorla na tanda tun sa thani di shugu res.
So as Brycela said, the direction of the force was not in the direction that we wanted the ball to move, but it was in the direction of the change in direction.
Ta tanda shuye jura di shuye di kerangi polo khajo gyur dicho gyur go samni shuye jura di chigiyo mares kerangi polo gi khajo gyurdan jura dil pa be shugiyo res susu gi kho gyur go du same jura dil shugiyo mare lawr.
So my question to you is, suppose Tashi hits the ball and the ball moves in a circle, but after a while Tashi gets tired, and when the ball reaches that point, Tashi stops hitting.
Ta tashi gi shuye go chu res polo dil shuyi do di korachi gyaswa ne tharan li du tashi thang che res an thang che du koi shuye zam sha res.
What will the ball do after Tashi stops hitting?
Ta de ne de le du gala tashi shuye zam sha re la ra zam sha du ani polo di khar chi res. It will move straight.
In what direction will it move straight?
Ta khap du dur la ra khajo khandes dur res. Khane dine do you want one of them to come up?
Would you like to come up and show us? So does it curve?
Ta dine dora this khuk de jo ro chida khuk res. Yes, it curved.
So let's actually see that.
Ta ngara jutta chu res diga.
Can the people in the front describe what they saw?
Ta kiran du la shunge de zo dishes kya da sa di khandes khorsons. Di tridan di tharan re. So that's the right pattern what he has drawn.
So this started to move and it continued to move.
Di yogu che go chu res and mitune yogu che de res.
In the same way that if I had a slingshot, if I had an object connected on a string and I would twirl it over my head, if that would break, that would move in a straight line.
Ta pe shaw na ngobo chi tanda kuba jil damba ina sra and dene korgya Portugal kuba di che na ngobo di chesani khapto dur wasma ngobo di todang di.
So the fact that the earth does not do that means that there must be a force that is constantly pulling the earth on its orbit.
Ta tanda di shuk di medu gal khapto duda di se kola di todang dele maras kor di ras di la du kola se kola la shuk ji thin di ras shuk ji gya di ras se kola di ga.
If the sun explodes right now,
Ta nima di kedo draw inas tanda.
it will take 8.5 minutes for us to know about it.
Ta kezor chimba inas an nganzo khadu hagurla na kama geda chega jel hapu resi draw di.
Because that's how long light takes to get to us.
Kaisna di yejura nganzo bodule la digas kurgu res.
And after those 8.5 minutes, the earth will start moving in a straight line.
Dila doni kama geda chega jela ani tanda se kola draw di res.
So, as Bryceler said, it is the force on Earth, on the planet Earth, by the sun that keeps it in its orbit.
Dilo du ni Bryce ki sheo na shi ta sai khola di khoram chik lo khor di do di khor chungi di se ni me tenshu di khor di gyores.
But our friend also asked an additional part to the question.
Ta tanda thiwa di gala engyo nembe thewa chik dus ne de.
And it had to do with the spinning.
Chik di khari gal shi la na rangor ge jora di gan te dus.
So let me get this spinning.
Di rangor ge chugi is ra.
Can everyone see it spin?
Chame si de sa di rangor ge de.
The floor is not horizontal, and so if I go very close, I hear the ball rubbing on the floor.
New shuju amju di nyeba inasra ngi khari kurla na tanda shala di da polo di dargyo jura di da di kures.
There's little pieces of dirt on the surface of the ball that rubs against the floor.
Ta digala thala do polo di ngogala yora di ani shala dargyo yures.
And so it is the rubbing with the floor that slows the spinning down.
Ta di dare jora dare di kengi ani rangor di theru du yures.
But there is no floor for the earth to rub against.
Hine ngara ju se khola imba ina tanda de ina shala do di do se khola kheyo mares tarsa.
So the earth continues to turn on its axis.
Cheza an se khola di kora gya di yures lishin.
Because it does not need something to sustain its spinning.
Dila du korangi kora gya jora dila ta ramdek chingi lagora dende chi gugu yo mares.
On the contrary, in order for it to slow the spinning down, it needs rubbing action.
Kesi ta korangi jose jora kore di kesi thero tang gugu yo na ani shugdo shimba ji gugu yo res.
But he probably doesn't want me to say this.
Korangi di kera Bryce la lab jindo yo mares.
But I know you guys think in very precise terms.
Ne kera jo samlo tandu kala thangi tak ta do dende rang samlo tangi yo res.
In several billion years from now, the earth is slowing down. The spinning, how fast the earth spins is slowing down.
Ta sai khola rangor ge yo la roas. Di ta therbu mangbu jelta oina da thanda khore jora rangor ge digi ani theru dugu yo res.
After many billion years, it'll stop spinning.
Ani therbu mangbu shu jela lo ani rangor ge di jam shag res.
But before that happens, don't worry,
Ne di ma chang mo la sembe shu mares.
our sun will explode.
Di ma chang mo la ngaju ni ma jora di kedo du res.
And anything living on this planet will be annihilated.
And
Destroyed.
okay. Ta di jela ani to kedo drona hachire se khola jora ngara jo sa di chajang chado du res.
But in the history of humans on this planet, how fast the Earth's spinning has not changed in any way in any way that matters. It's such a small change, it's almost no change.
Ta rangor ge yo la ra dil gyo du yo res gyo chunju shu yo res di chajang ani ngaju di chime ta ona shida chigi yo mares di. Keba shira su yo mares chungran.
So once again, the laws of motion tell us that there is no force needed to sustain motion. There is a force needed to change the motion.
Ta tanda tentim gi yogu gi tentim jula de shusum draw ina ini tanda yogu che de gala ya shu gugu yogu che de la yang shu gugu yo la na di gugu yo mares ta yogu che de yo di tanda khacho jur gugu yo na ani shu ji gugu yo res lan lagi yo res.
We will do more about gravity a little bit later in the workshop.
Ta sabjong gi past to de ni tanda ngaju gi tenshu korla ni thigi is.